Dear students, welcome to today's class. Today I am going to introduce a very important branch of mathematics, that is calculus. Okay, so here onwards, today onwards, within next few days, I start to teach calculus. Okay, so this is the first class of the calculus. Okay, now don't skip any videos from the beginning itself. Every day follow my classes. You can easily understand the concepts of calculus. So in your JEE mains examination also, you are getting a good number of questions, not only in JEE mains and JEE advanced and all board examinations also. You are getting a good number of questions from this branch of mathematics, that is calculus. So very easy and very interesting topics are there. Okay, so first let me introduce what is a limit of a function. So already we know number of times what is a function. Function means if A and B are two non-empty sets, a function is a rule that assigns every element of 2 a unique element of B. That everybody knows function. Then what is the limit of that function? What is the limit? What is the limit of the function? Okay. So to introduce that, I will explain this concept taking a very small example so that everybody can understand easily. Let us define a function f from R to R as f of x is equal to x plus 1. Very simple definition. Here domain is set of real numbers and codomain is also set of real numbers. Here the function is defined as f of x is equal to x plus 1. That means what is the meaning of this generally? So this is A and it is B. Your function name is f. Your function name is x. For your element, its image is f of x, that is given as x plus 1. Right, clear? So what is the image of 1? It is 2. What is the image of 2? It is 3. What is the image of 2? It is 3. Clear? So for every element, so the function is from R to R. Right. See here, f of 2 value is equal to the value of 2 in the function x is 3. For the function f of x is equal to x plus 1. The image of 2 is 3. So this 3 is called functional value of 2. This 3 is called functional value of 2. This 3 is called functional value of 2. At exactly 2, its image is 3. Now what I am going to do is, in this limit of a function, as x value approaches to 2, that means your x value is exactly it is 2, at exactly 2 the image is 3, but as x value approaches to 2, as x value, that means the variable x approaches to 2, that means what is the behavior of the function f of x is equal to x plus 1. What is the how it moves? At exactly 2, its image is 3. But as x value approaches to 2, that means if it approaches from right side and it approaches to from left side, what is the image of 2? What is the behavior of the function f of x is equal to x plus 1? Okay. So let us see that behavior using a table. Let us observe this table. Here in the function f of x is equal to x plus 1, the variable is x and our function is f of x is equal to x plus 1. Now what I am going to do is, as x value approaches to 2, the x value is approaching to this. Approaches to means what? It may approach from right side and it approaches from left side. Let us see the functional values of f of x is equal to x plus 1. Let us observe the behavior of f of x is equal to x plus 1. Now when x is equal to 2.5, then f of x plus 1 value is 3.5. Okay. When x is equal to 2.4, f of x is equal to x plus 1 value is how much? 3.4. So this is a 3.3. So we are still approaching 2 from left hand side. So that is equal to, this is a 3.01, 3.001, 3.001. That means we are still approaching x to 2 from right hand side. Okay. Still this is equal to 3.0001. Now let us move approach to the variable the value 2 from left hand side. Okay, now so as x value is 1.6, this is equal to 2.6. Okay, now 1.6 plus to 2.6. So here 1.6 plus 1, 2.6. This is equal to 2.7. This is 2.8, 2.9, 2.99, 2.999, 2.999. What do you observe? As x value approaches to 2, that means we will write it as x value approaches to 2, your f of x value approaches to 3. Your f of x value approaches to 3. So here you have to take care, one thing you have to remember in that x is not taking the value 2. X is not taking the value 2, but it is approaching to 2. That is the process you have to understand here. Then your f of x value, see here 2.999, 2.9999. 2.999 means what? It is still approaching to 3 from left hand side. As you move close to 2, so your f of x is also moving close to 3. That means what is the limit? That means the stoppage point. So where it is moving 2.999, next one 2.999, but it never takes 3. It never takes 3, so it is approaching to 3. F of x value is approaching to 3. It cannot cross 3. It cannot cross 3. Understand? Why? Because your maximum you are approaching to 2. So therefore maximum you can move to the f of x value can move up to 3. That's why this 3 is called, that 3 is called limit. Limit. Generally in our day-to-day life also we use the word limit. So we should have some limits in our day-to-day life. Okay, we should not cross the limits. If we cross the limits, what happens? Everything will be, our life will becomes chaos and confusion. Okay, now right, everything will be spoiled. Here also the limit of that function is 3 only. When x value approaches to 2. When your x value approaches to, then the limit value also approaches to 3. So x cannot take 2, here f of x also cannot take 3. Here you have to observe the process, what happens. That means the limit of this function f of x is equal to x plus 1. The limit of the function f of x is equal to x plus 1 as x approaches to 2. This symbol means x approaches to 2 is 3. The limit of this function, so this is the word first I am using. The limit of the function f of x is equal to x plus 1 as x, here the variable is x, x value approaches to 2 is 3. So this is the limit of that function. Okay, now, right. Such a long word, such a long sentence can be symbolically written as, limit of x plus 1 as x tends to 1, as x tends to 2 is equal to 3. Like that we can write it as. Still in short, we can write it as limit x tends to 2, x plus 1 is equal to 3. But you have to observe here, we are not simply substituting x is equal to 2 in place of the variable. We are not still substituting x is equal to 2 in place of x, but what the process it is going on, that we have to take observe carefully. That means as x value approaches to 2, the function f of x is equal to x plus 1 approaches to 3. So when you are saying approaches to or moves to or close to, so we are approaching from left hand side and right hand side. So when you approaching x from right hand side, you have to write symbolically it as this side x approaches to 2 plus. To top you write down plus. Here x value approaches to 2 from left side. Here you write down x approaches to 2 minus. X approaches to 2 minus. So now we will write it as limit x tends to 2 minus f of x. That is, here f of x means how much? X plus 1 is equal to 3. This is called left hand side limit. This is called left hand side limit. Here RHL, right hand side limit. That means you are approaching 2 from right hand side. Right hand side limit, limit x tends to 2 plus x plus 1 is equal to 3. 2 plus. In place of x substitute 2 plus 1, 3. Understand? So this is the left hand side limit and the right hand side limit. Both left hand side limit and right hand side limits are both are equal. Then we write it this. Then write it the limit x tends to 2. That is x plus 1 is equal to 3. That means to exist a limit, both its left hand side limit and right hand side limit both should be equal. Then only the limit exists. Sir, is there any functions which are left hand side limit and right hand side limit will get a different answers? Yes, there are some certain functions which left hand side limit approaches to one value and right hand side limit approaches to another value, thereby limit does not exist. Okay, now I will explain that example also. Okay, let us see that example. F is a function defined from set of real numbers to real numbers. It is defined as f of x is equal to x square plus 1 when x is less than or equal to 1. When is x is less than or equal to 1, and 4x when x is greater than 1. Okay, now, so this is called branch-wise function or piecewise function. Piecewise function. That means here the domain is x less than or equal to 1 and x greater than 1. That means the domain is set of real numbers only. So the 1 is the breaking point. From 1 to the left side, the function is defined as x square plus 1, and from 1 to right hand side, the function is defined as 4x. Okay, now, so this type of functions are called piecewise function. That means the domain is divided into pieces. So luckily here only 2 pieces, 1, 2. So there are some functions it is divided into 3, 4, 5 pieces are also. Now as x value approaches to 2, let us see what is the limit of this function f of x. Okay, now, so see here, if you observe this, I will draw a diagram. So here 1, as x value for 1 x less than or equal to 1, your function is defined as x square plus 1, and for x greater than 2, the function is defined as f of x. Okay, now, so right side of 1 is 4x, left side is equal to x square plus 1. Now let us see the left hand side limit of this function. So left hand side limit is equal to limit x tends to 1, just a symbol minus. This is a 1, the top minus symbol is, it is not, so this is symbol means 1 minus means it is not equal to minus 1. Don't think that. 1 minus means what? We are approaching the variable x that is equal to 1 from left hand side. Okay, now, so what is the function definition there? So the function is x square plus 1. This is obviously 1 plus 1, 2. That means as x value approaches to 1, your function x square plus 1 value is approaches to 2. Now coming to right hand side limit, limit x tends to 1 plus. Okay, now what is your function right hand side, how it is defined? 4x it is defined. So already as earlier I have given one explanation. So as x tends to 1, 4x value approaches to 4. So observe here, the left hand side value is 2, the right hand side value is 4, the left hand side limit is 2, right hand limit is 4. We say that limit x tends to 1, f of x does not exist. So limit x tends to 1, f of x does not exist. Okay, now, right. So this is a that means what? Given a function as x tends to 1, if it is a limit exists, we have to check for both left hand side limit and right hand side limit. Okay now. So let us see few more concepts in this limit of a function. In this here I am going to explain some fundamental theorems on limits. Okay now. The first fundamental theorem is limit extends to a f of x plus or minus g of x is equal to. If there are two functions are there, f of x plus g of x, another function f of x minus g of x. So this is equal to limit is f of x plus or minus limit extends to a g of x. That means you can separate the limits for both the functions. You can separate the limits for both the function. Otherwise, if it is a minus symbol is there, you can take the minus also. Okay now. So this for this all these theorems proofs are there. Proofs are there for our examination point of view or some competition point of view. So no need of learning the proofs. Okay. Just we will make use of the result to solve the problems. Okay. Now coming to second one. So this is a addition over between two functions. We can extend this function we can extend this theorem also. That means f of x plus g of x plus h of x plus so on, some n number of functions are there. You can apply the limit of extends to a to any number of functions. Okay now, right. Coming to limit extends to a, if it is product is there, f of x into g of x. Okay, f of x times g of x. Then also you can separate the limits. That is limit extends to a f of x into limit extends to a g of x. You can separate the limits. So this also you can extend to n number of functions. That means f of x into g of x into h of x into k of x into l of x is there, such like that n number of functions is there. You can also apply this limit extends to a to n number of functions. Okay now. Now coming to here, limit extends to 0, addition is over, subtraction is over, multiplication is over, division. So that is equal to, so f of x divided by g of x. This is called rational function. Already we have given a definition of rational function. So the rational function g of x should not be equal to 0. That means, so that is you can separate the limit also upon limit extends to a g of x. Okay now, provided the condition is limit extends to a g of x should not be equal to 0. Okay now, that limit of the denominator function should not be equal to 0. If it becomes 0, what happens? You know, that is the denominator cannot be equal to 0. If it is equal to 0, that cannot be the real number. Okay, right. Now coming to fourth one, limit extends to 0 k times f of x, where k is any constant. K times f of x means k is any constant. That means what? K times f of x means what? F of x plus f of x plus f of x, k number of are there. F of x plus f of x plus f of x. You can separate the limit also. That means k limits will come. That means k into limit extends to a f of x. Understand? K times f of x means f of x plus f of x plus f of x. K number of f of x's are there. Each one f of x limit you can separate. How many limits are there? K limits are there. So therefore you can write down k into limit extends to a f of x. That means what? If any constant is there, you can take the constant outside. So this is equal to, I hope this 61. So this is equal to limit extends to a f of x whole power n. Sum is there. So f of x whole power n is there. This is same as limit extends to a f of x whole power n. Whole power. That means here the power is for only the function f of x. Then you can put whole power. The proof is also very easy. F of x whole power n means what? F of x into f of x into f of x n times. Okay, now you can apply the limit for each function as I told in the first fundamental theorem. That means what? Limit extends to a f of x into limit extends to a f of x into, like that how many will be there? N will be there. That you can write down as limit extends to a f of x whole power n. Proof is very easy. Now sixth one is For example, limit extends to a f of x to the power of g of x is there. Function to the power of function. Okay, na? So just like exponential functions, logarithmic functions, such type of functions are there. No, some exponential function a power x, e power x, sin x to the power of cos x, like that functions are there. So this you can do it like this: limit extends to a f of x to the power of limit extends to a g power x. Limit extends to a g of x. That means you can separate the limit for the base and the exponent. For both base and exponent, you can separate. For both of them, you can. For example, if you come across anywhere some limit extends to pi by 2, other some limit extends to pi by 6, sin x to the power of cos x is there. Limit extends to pi by x, sin x to the power of cos x is there. So what is the value of that? So you can apply limit for both base and power. Limit extends to pi by 6. That means pi by 6 means 30. Sin 30 is equal to 1 by 2. Cos 30 is equal to root 3 by 2. So this is your answer. 1 by 2 to the power of root 3 by 2. Understand this? Okay. Like that you can apply the limit for both base and power. Now coming to 7th property and 8th property. So here so one more function. So composite functions are there. If it is composite functions are there, that means what? F circle g of x. So here f circle g of x is equal to f of g of x. G circle f of x is equal to g of f of x. G circle f of x is equal to g of f of x. Okay, now. So that is equal to limit extends to 0 f of g of x. It is there. It is a composite function, that is a product function. Already in the function chapter I explained. So this can be written as f of limit extends to 0 or extends to a g of x. That means you can apply the limit to g of x. Whatever maybe the value will come, that is f of l will come. For example, if it is there, limit extends to a g of f of x is there. This is g of limit extends to a f of x. That means you can apply the limits in the inside the function. Okay, now. So I hope that you understand these fundamental theorems on limits. Some more inequality functions are also there. So these are all equality. So some more inequality functions are also there. So let us see that inequality functions also. There are some certain functions are there which are inequality type of functions. What are those things? Let us see this. For example, f of x is less than or equal to g of x for all x belongs to the domain. That means whatever maybe the functions are defined from that is for all x belongs to the domain, or f of x is less than or equal to g of x. Then also limit extends to a f of x is less than or equal to limit extends to a g of x. Okay, now the same concept applies for greater than also. If f of x is greater than or equal to g of x, the same concept applies. Limit extends to a f of x is greater than or equal to limit extends to a g of x. No need of even though strictly less than and strictly greater than is there, the concept will be same. Not only for two functions, if it is even though more than two functions are also there. For example, f of x is less than g of x is less than h of x. F of x is less than g of x is less than h of x. Then also limit extends to a f of x is less than limit extends to a g of x is less than limit extends to a h of x. Then also the less than will come. Okay, now, right. So these are the fundamental theorems on limits. Okay. So just one more theorem I have missed here. That missed means limit extends to a modulus of f of x. Limit extends to a modulus of f of x. This is same as modulus of limit extends to a f of x. limit extends to a f of x is same as modulus of limit extends to a f of x. That means what? You can put the modulus outside. Okay, na? So these are the fundamental theorems on limits. Okay, na? So I hope that you understand all these fundamentals. So write it on a book separately. So therefore now some more formulas will come. Let us see that formulae. Welcome back to one more concept. So here there are some indeterminate forms are there. So what is meant by indeterminate? The name itself it is saying determinate means we can find, we can measure, we can calculate. Indeterminate means we cannot calculate. There is no meaning for that. That is 0 upon 0, infinity upon infinity, infinity minus infinity, 0 into infinity, 0 power 0, infinity power 0, 1 power infinity. These forms are called indeterminate forms. Sir, where we get this type of forms are, for example, if I am explaining one problem. So here limit x tends to 2, x square minus 4 upon x minus 2. So one problem is there, limit x tends to 2, x square minus 4 upon x minus 2. So as usual, how we will do the problem? Already we have formula. So that is limit x tends to a, f of x is equal to how much? F of a. That means in place of the variable x, we have to substitute that limit x tends to a value have to substitute. So basing on that concept, we will substitute here wherever x there, substitute 2. That means 2 square minus 4 upon 2 minus 2. Clearly it is 0 by 0 upon 0. Now is that answer? That is the answer 0 by 0. Is this function approaches to 0 by 0 now? What is there any meaning for that? So any function should approaches to a finite value. It cannot approaches to an indeterminate form. What is the meaning of that 0 by 0? Okay, the function should, as clearly x value approaches to 2, a finite value, the function is also should approach to a finite value which cannot be this form. Then what will be the answer? Therefore, the limit does not exist. Limit does not exist. Therefore, we can leave this problem. No. So, can we simplify this function? Can we simplify this function? Yes, we can simplify. This is equal to limit x tends to 2. We can write the numerator as a square minus b square, a plus b into a minus b, under denominator x minus 2. As x value is not equal to 2. See here, while cancelling x minus 2, as we do we have any right to cancel? As we have a right when x minus 2 are not equal to 0, then only we can cancel. Okay, now yes, that x minus 2 cannot be equal to 0, x minus 2 cannot be equal to 0. Why? Because as x value is approaches to 2, here x cannot be equal to 2. If it is x is equal to 2, then 2 minus 2 0, 2 minus 2 0, 0 by 0 will come. So as x value approaches to 2, therefore x minus 2 value cannot be equal to 0. Here also x minus 2 value cannot be equal to 0. Then you can cancel x minus 2 you can cancel. Okay, now as x tends to 2, substitute 2 plus 2, 4. 4 is your answer. Understand? 4 is your answer. 4 is a finite value. That's why this is your answer. And one more thing also, generally students have an opinion about this 0 into anything. They will say that 0 into anything is 0. That is wrong. 0 into a finite value. 0 multiplied by finite value. Then only it is equal to 0. Finite value means what? Any real number, defined value. Root 2, yes, 0 into root 2 is how much? 0. 0 into 5 is how much? 0. Understand? So 0 into 1 by 2 is equal to how much? 0. That means what? These should be finite values, real numbers, defined terms, determined terms. If it is indeterminate form, that means 0 into infinity, it is cannot be equal to 0. Understand? 0 into infinity, it cannot be equal to 0. Okay, right. So that also you should be take in mind. So like that 1 to the power of infinity also cannot be equal to 1. Generally students they have the opinion that 1 to the power of infinity is equal to 1? No. 1 to the power of a finite value. 1 to the power of here one finite value, then only that is equal to 1. That is 1 square is equal to 1, 1 cube is equal to 1, 1 power 5 is equal to 1, 1 power root 2, 1 power root 2 is equal to 1. Understand? 1 power root 3 by 2 is equal to 1, but 1 power undefined is not equal to 1. Understand? Same here also, 0 to the power of anything 0. No, 0 to the power of 0 is indeterminate form. 0 to the power of 0 is also indeterminate form. Infinity to 0, that is indeterminate form to 0. Infinity to 0 is also, generally student think they with that. So if it is a 5 to the power of 0, its value is 1. 6 power 0, its value is 1. But it is infinity to the power of 0, it cannot be equal to 1. Okay, na? So whenever if you get these forms, after substituting the limit extends to a, if you get any of these forms, that is not your answer. That is not your answer. That means you have to do something, some calculations, some addition and subtraction, some multiplying the numerator and denominator, and some simplifications you have to do, and you reduce the function for a defined value of x tends to 2, then you will get a finite value. Okay, na? So I hope that you understand all these indeterminate forms. So remember that these are only the indeterminate forms only. Okay, na? I hope that you understand this concept. Let us go for next concept. Now here I am going to explain a very important fundamental theorem. It's a proof I am going to explain. So for all real values of n, limit extends to a x power n minus a power n upon x minus a is equal to n into a to the power of n minus 1. So here we have three different cases when n is an integer, n is a rational number, and n is a negative integer, n is a positive integer, n is a rational number, and n is a negative integer. Different three cases will be there for the proof. Now I am taking the general proof. Now to prove this, so limit extends to a x power n minus a power n by x minus a is equal to n into a to the power of n minus 1. So to prove that, first I will write down the formula of x power n minus a power n. X power n minus a power n. So this formula is given as x minus a into x power n minus 1 plus x power n minus 2 into a plus x power n minus 3 into a square plus so on a power n minus 1 formula. Sir, how can you remember, sir, such a type of lengthy formula? Means I will tell you a small trick. So in the board examination also, this is a very important proof this is. So I will tell you a small example. For example, you see here I am writing a minus b value formula. You see here in algebra, you know the formula. A minus b is equal to how much? A minus b. A square minus b square value, a minus b times a plus b. Okay, na? Right. What is a cube minus b cube value? A cube minus b cube formula is, what is a cube minus b cube formula? A minus b times a square plus ab plus b square. What do you see here? See here. What is the thing you observe here? A square minus b square, a minus b. A cube minus b cube, a minus b. What is the second factor? Observe the second factor. If it is a cube is there, here a square is there. That means 1 reduced. The power is, the exponent is 1 reduced. Again here a, here b will start and b square will come. That means the powers of a are reducing 1 and the powers of b are increasing to 1. They are going on increasing the powers of a. So from this you can write down a power 4 formula also you can write down. A power 4 minus b power 4. Now tell me what is a power 4 minus b power 4 formula. So this is equal to a minus b times a cube plus a square b plus ab square plus b cube. That is the formula. Observe here, a minus b is compulsory. Here a power 4 means first a cube will come, next a square will come, then b starts, and next a square is over, no a, b no b square, next b cube, like that. That means the powers of a are reduced to 1 and powers of b are increasing to 1. So, the same concepts are here. Here x power n, therefore x power n minus 1, x power n minus 2, x power n minus 3, so on. Here a power n, it starts from second term, a square, last term is a power n minus 1. Very easy one, very easy one. Now take this x minus a to left hand side. So take this x minus a to left hand side, x power n minus a power n upon x minus a, that is x power n minus 1 plus x power n minus 2 into a plus x power n minus 3 into a square plus so on a power n minus 1. Okay. So apply the limit extends to a on both sides. So limit extends to a x power n minus a power n by x minus a is equal to limit extends to a x power n minus 1 plus x power n minus 2 into a plus x power n minus 3 into a square plus so on a power n minus 1. So as usual we have to know the definition. X tends to a, wherever x is there, substitute a, that is equal to a power n minus 1 plus a power n minus 2 into a power n minus 3 into a square plus so on a power n minus 1. So this is equal to, the first term is equal to how much? A power n minus 1 plus a power n minus 2 plus 1, a power m into a power m plus n minus 2 plus 1, a power n minus 1, their power n minus 1 plus so on a power n minus 1. This type of a power n minus are, how many are there? They are n times are there, n times a power n minus 1. Sir, how can you say that? Say that a power n minus 1s are n are there. Let us see the check here. A square minus b square. Here how many terms are there? A plus b, 2 terms. A cube minus b cube. See here a square plus ab plus b square, 3 terms. A power 4 minus b power 4, 1, 2, 3, 4, 4 terms. Similarly, x power n minus a power n means what? These are how many terms should be there? How many terms should be there? N terms should be there. That means a power n minus 1, a power n minus, how many n minus 1s are there? N into n a power n minus 1s are there. That's why n into a to the power of n minus 1. So very, very easy. So this is a general proof I am telling, but actual perfect proof is, here n you have to take the integers here. N is an integer you have to take. Afterwards you have to take the rational numbers, positive integers. This is a positive integer for rational number. That means n is equal to p by q form is also, that proof is also there. N is equal to p by q. So wherever n is there, substitute p by q. P by q like that. Okay, now that proof is also there. Next, n is a negative integer. Negative integer means, so n is equal to minus m, where m greater than 0, like that. So wherever n is there, minus m will form. X power 1 by x power m, that formula. Okay. Okay, like that proofs are also there. So dear students, I hope that you enjoyed today's class. So tomorrow onwards, let us start some more concepts and some more formulas I will explain, and I will immediately I will start to explain the previous year JEE mains examination questions systematically, detailedly I will explain. Okay, now I hope that you enjoyed today's class. Let us see in the tomorrow's class.